This video is going to be about the Pythagorean Theorem. Now, I've used the Pythagorean Theorem a little bit in class, but this video is going to go into detail on the formula, how to set it up, and how to solve some problems. The first two things that we need to know is when we can use the Pythagorean Theorem and what it's used for. So we can only use the Pythagorean Theorem in right triangles. So it's not going to work in any other kind of shape. So we need to have a right triangle in order to do this. Also, it's used to find a missing side when we're given two. So that means we have to be given two sides of a right triangle, and we need to be looking for the third. That's when we're going to use this Pythagorean Theorem to find our missing side. So let's first talk about the formula itself and what it looks like and what the different parts are. So the Pythagorean Theorem formula is going to be given to you on the regions. It's on your reference sheet, but it is a squared plus b squared equals c squared. Now, the most important part about this formula is what c squared is. C squared is always going to be the hypotenuse. That's very, very important. It's always going to be the hypotenuse. These two, A and B, don't really matter. They're going to be the two legs, and it doesn't matter what order we use them. We just have to make sure that we always fill in our hypotenuse. And if we don't remember, the hypotenuse is always either the largest side or it's across from the right angle. So we can look at that either way. It can either be the largest of three sides, but since we're looking for one of the three, the easiest thing we can do is look across from the right angle. So let's jump right into the first example that we're going to do. So in this triangle here, we're going to solve for the length of C. Now, I'm given 4, I'm given 6, I'm looking for C, and I have a right triangle. So that tells me I'm going to use my Pythagorean Theorem. So, since I know I'm going to use my Pythagorean Theorem, I would start by writing out my formula. A squared plus b squared equals c squared. Alright, the next thing I'm going to want to do, that I always like to do first, is I like to fill in my c squared first because that's the most important. It's my hypotenuse. So I know that my hypotenuse is always across from my right angle. So I know that in this case it's actually also going to be c. So we're going to write this in as c squared. Now, as I told you before, the other two don't matter. One can be A, one can be B. It doesn't make a difference which way you write it. Okay, the 4 can go first, the 6 can go first. It really doesn't matter. So I'm going to write these in as 4 squared plus 6 squared. Now from here, we're just going to solve this equation as we normally would using algebra. So 4 squared is 16, 6 squared is 36, and we are equal to c squared. We're going to simplify this. We're going to get 52 equals c squared, and we're going to square root both sides to get c by itself. Now, after learning what we did this week, we can break down the square root of 52. So this is not how we're going to want to leave our final answer. Our final answer is going to want to be broken down. You guys use your graphing calculator, your y equals key, and you would come up with 2 square root of 13 equals c. This is going to be our final answer. Alright, so using the Pythagorean Theorem, a squared plus b squared equals c squared, we have our two legs, and we have our hypotenuse filled in. And we solve using our algebra methods here, square 4, square 6, add them together, square root both sides, and then break down our square root here. Alright, we're going to do another problem next. That looks just a tiny bit different, but still has the same concept. Alright, so now, this time we're going to solve for x. Again, I have a right triangle, and I'm dealing with 3 sides. So I know that tells me that I want to use my Pythagorean Theorem. So I'm going to set up my a squared plus b squared equals c squared. In the same way I did before, the first thing I'm going to fill in is my c. And I'm going to look across from my right angle. So this side across from my right angle is 26. Now this time, that's what's going to go in for c squared. So it's going to be a little different for us to solve for our missing piece this time. And now, as I said before, 24 and x doesn't matter. Doesn't matter which one's A, which one's B. I'm going to put 24 first, and I'm going to put x second, and set it equal to 26 squared. Now from here, we go through our algebra. 24 squared is 576 plus x squared equals square root of 26 is 676. Now, we have to get x by itself. Okay, so it's going to be kind of like our two-step equation. We're going to subtract 576 from both sides. and we're going to get x squared equals 100. Now, when we square root both sides this time, 100 is a perfect square. So we don't have to go through the simplification process or simplifying it in our calculator. We just have our final answer as x equals 10. And that's where we'd stop. Alright, so these are both cases that you're going to come across when using the Pythagorean theorem. This one requires a little bit more algebra because we have to subtract to the other side. So just make sure you pay attention to which piece of information is missing and how you're going to solve once you get your equation all set up. Alright, there is one other question they can ask. This one usually comes up as a multiple choice, but it's really the same concept. So this one wants us to know, this one is asking us if this triangle is a right triangle. So in order for it to be a right triangle, we can use the Pythagorean theorem and see if it works. So if these three sides, 3, 4, and 5, work within this formula, then I know it has to be a right triangle. So this time, since I don't have a right angle, and I have all three sides, my biggest side, 5, is going to be what goes in for C. So I'm going to have 5 squared here. And again, 3 and 4 don't matter, but I'm going to put them in. 3 squared plus 4 squared equals 5 squared. Now, 3 squared is 9, 4 squared is 16. When I add those two together, I get 25. Now, on the other side of my equal sign, 5 squared is also 25. So these three numbers work in the Pythagorean theorem, so yes, this is a right triangle. Alright, so those are the three types of problems that you would come across with the Pythagorean theorem. Alright, so just to go back and scroll up and break it down here, this one, solving for C, is solving for the hypotenuse. Okay, make sure we can plug in 4, 6, looking for C, solve, and then break down the radical. Make sure you get that last step in. The other thing that we came up with here is we were given the hypotenuse this time. We were given 26, and we were looking for one of the legs. So we made sure our 26 went in for C, and again, went through our algebra to solve. And then the last type of question that you could see is all three sides asking you if something is a right triangle. If that's the case, plug in all three sides and see if your equation works.